If light is the fastest thing in the universe, why does time slow down when you start moving? Richard Feynman said we're not just watching light, we're staring at the edge of reality itself. Close your eyes for a moment and imagine a universe with no light, no stars, no colors, no faces, no sense of distance, just endless, silent darkness. In that world, there is no where and no when. Nothing moves because nothing can be seen moving. The simple act of looking at something is what gives the universe its shape. Now open your eyes. Every second, trillions of tiny messengers are crashing into them. They've traveled from the sun, from distant lamps, from glowing screens, and even from stars that may no longer exist. We call them photons, but most of the time we don't think about what they really are. We just assume light is something that moves very, very fast. Richard Feynman didn't like that answer. He believed that when something seems too simple, it's usually hiding a deeper truth. So instead of asking how fast light moves, he asked a stranger question. What would the universe look like if light didn't have a limit at all? Imagine flipping a switch in a dark room and seeing everything instantly, not a fraction of a second later, not even a blink later, just instant. In that kind of universe, there would be no delay between cause and effect, no waiting, no surprise. Everything would happen all at once, everywhere, and that's when the idea becomes unsettling, because the universe we live in doesn't work like that. There is always a delay, even if it's tiny. A pause between something happening and you knowing it happened. That pause is what gives the world depth. It's what creates distance. It's what allows before and after to exist at all. Feynman realized that the speed of light isn't just a number, it's a rule, a boundary, a line the universe refuses to cross. Every message, every signal, every glimpse of reality has to obey it. When you look at the stars, you are not seeing them as they are. You are seeing them as they were. Some of that light began its journey before humans ever walked the earth. Some of it left its source before those stars even knew they were about to die. So the sky above you is not a picture of the present. It's a layered archive of the past, spread across space. And here's the strange part. If nothing can move faster than light, then nothing can outrun the flow of time either. Space and time become tied together, stitched by this single, unbreakable limit. Which means light isn't just showing you the universe. It's shaping how the universe can exist at all. Once you accept that light is a limit instead of just a traveler, the universe starts to feel less like a stage and more like a machine with rules built into its bones. Everything that happens, no matter how small, has to wait its turn to be known. A clap of thunder, a flash of lightning, even the sound of your own voice reaching your ears is delayed by the same invisible law. Feynman loved to point out how strange this really is. If you were somehow able to move alongside a beam of light, matching its speed perfectly, something impossible would happen. From your perspective, the light would no longer move. It would be frozen in place, hanging in space like a glowing statue. No ticking clocks, no passing moments, just a single, endless now. That idea alone bends the mind, because it suggests that time itself depends on how fast you move through space. The faster you go, the slower time flows for you. At the ultimate limit, where light lives, time doesn't flow at all. So what is light experiencing? According to the rules of physics, a photon doesn't feel a journey. It doesn't feel distance. The moment it is created and the moment it is absorbed are the same moment from its point of view. 1 billion years can pass for the universe, while for the photon, nothing passes at all. Feynman saw this as one of the deepest clues about reality. It means the universe is not built from solid objects moving through empty space. It's built from relationships between events. One thing happens, then another, and the connection between them is carried by light. Without that connection, there is no story, no cause, no effect. Even your own body is part of this chain. When you touch something, your brain doesn't feel it instantly. Signals race through your nerves, limited by the same cosmic speed limit. Your experience of now is actually a tiny slice of the recent past, stitched together by delayed information. So you are never truly living in the present moment. You are living in a carefully assembled version of what just happened. And yet somehow, it feels continuous, smooth, real. That's the trick. The universe hides its delays so well that we mistake them for immediacy. We feel like we are directly connected to the world, when in fact we are always one step behind it, watching a stream of light-built messages arrive and turn into experience. This is where Feynman's rule becomes unsettling. If everything you know about reality comes to you through light, then reality itself is filtered, edited, and shaped by this single, unbreakable speed. You don't just see the universe. You see the version of it that light allows you to see. This realization leads to a strange question that Feynman loved to play with. If light controls how reality reaches you, then what is reality like when no one is looking? The universe is full of events happening in distant corners of space, collisions between stars, particles being born and destroyed, galaxies drifting apart. But none of it becomes part of your world until light carries the news across the cosmic gap. In a sense, the universe is always ahead of you. Every moment you experience is a delayed broadcast. The room around you, the screen in front of you, even the face you see in the mirror are slightly older than you think. The difference is so tiny you can't feel it, but it never disappears. There is always a gap between what is and what is known. Feynman saw this gap as more than a technical detail. He saw it as the space where mystery lives. Because if nothing can outrun light, then nothing can send information into your present from the true now of the universe. You are sealed inside a bubble of past signals, drifting forward through time, collecting fragments of reality as they arrive. Now imagine scaling this idea up. When astronomers look deep into space, they are also looking deep into time. A distant galaxy is not just far away, it is young. You are seeing it as it was millions or billions of years ago, before planets formed, before civilizations could ever exist. The night sky becomes a museum of cosmic history, frozen in glowing points of ancient light. And here's the unsettling twist. Some of the stars you see may already be gone. Their light is still traveling, still telling their story, long after the source has vanished. In a very real sense, the universe is full of ghosts, messages from things that no longer exist. So what does that make you? Your thoughts, your memories, your sense of self are also built from delayed signals. Electrical pulses in your brain, chemical reactions in your cells, all obeying the same limits. The you that feels present is actually a pattern assembled from the recent past, constantly updating itself as new information arrives. Feynman didn't see this as depressing, he saw it as beautiful. It means reality is not a solid block you live inside. It's a flowing story, written by light as it connects one moment to the next. You are not standing in the universe like a statue. You are riding a wave of information, always moving, always becoming. And if that's true, then the speed of light isn't just a boundary. It's the rhythm of existence itself. Once you start thinking of light as the rhythm of existence, another question quietly rises to the surface. If reality is built from information traveling at a fixed speed, then what happens at the edges, where that information can barely reach at all? The universe is expanding, stretching space itself like fabric being pulled apart. And in some regions, that stretching happens so fast that light from those places will never, ever arrive here. Feynman would have loved that idea. It means there are parts of the universe that are not just far away, but permanently unreachable. No matter how long you wait, no matter how powerful your telescope becomes, their stories can never be told to you. They exist beyond your cosmic horizon, outside the bubble of reality you can ever experience. So your universe, the one you live in and think about and try to understand, is not the whole universe at all. It's a window. Inside that window, everything you know is connected by light. Outside it, there may be galaxies, stars, and events that will never touch your awareness, not even as a faint glow in the night sky. Their existence is real, but it is not part of your story. This creates a strange kind of intimacy. Every star you can see, every distant galaxy captured by a telescope, is part of a shared network of signals. They have managed to reach you. They have crossed the vastness of space and time to become part of your moment. Right now. In that sense, the visible universe is not defined by size. It's defined by connection. Feynman often reminded people that physics is not just about measuring things. It's about understanding what can influence what. The speed of light draws the ultimate map of influence. It tells you which events can affect you and which ones are forever beyond your reach. Even your own future is shaped by this. You cannot be affected by something that hasn't had time to send its message to you yet. And once that message arrives, it becomes part of your present, changing your decisions, your movements, your thoughts. So life itself becomes a dance with delayed information. You act based on what you know, but what you know is always a snapshot of what just was. The world moves ahead, and you follow, guided by a trail of light that never quite catches up to the source. This might sound like a limitation, but Feynman saw freedom in it. Because within this boundary, the universe becomes predictable, structured, and meaningful. Causes lead to effects. Stories have beginnings and endings. Time has a direction. Without the speed of light, everything would collapse into a single, overwhelming instant. With it, reality unfolds, moment by moment, giving you space to exist, to choose, and to wonder. And maybe that is the most surprising rule of all. If reality unfolds moment by moment, guided by this cosmic speed limit, then the question becomes personal. Where do you fit inside a universe that is always one step ahead of your awareness? Feynman believed that this was where physics quietly touches philosophy, not by giving answers, but by changing the way you see yourself inside the story. You often think of yourself as a center, a point where everything comes together. Your thoughts, your memories, your plans for the future all feel immediate and direct. But in a universe shaped by light, even your own mind is part of the same delayed network. Every sensation you feel is a message that had to travel, even if only a few centimeters, before it became part of your experience. So, the now you live in is not a single point in time. It's a thin layer, constantly being refreshed by incoming signals from the world around you. Feynman liked to remind people that this doesn't make reality weaker. It makes it richer, because if everything were truly instant, nothing would stand out. There would be no anticipation, no memory, no sense of change. The fact that information takes time to arrive is what allows you to feel surprise, to learn, to grow. Think about a conversation. You speak, and a fraction of a second later, the other person hears you. They respond, and another tiny delay passes before their words reach you. In that simple exchange, light and sound are quietly choreographing a dance of cause and effect, creating a shared moment out of two separate experiences. Scale that up to the universe, and the same thing is happening everywhere. Stars are talking to space with light. Galaxies are whispering their existence across billions of years. And you are listening, catching fragments of those messages and weaving them into a picture you call reality. This is where Feynman's view becomes almost poetic. He suggested that the universe is not a collection of objects, but a conversation, an endless exchange of information, limited by a single unbreakable rule about how fast that conversation can travel. You are not standing outside of it, observing from a distance. You are part of it. Every time you look at the sky, every time you notice a shadow or a reflection, you are participating in this cosmic dialogue. You are both a receiver and a sender, adding your own small signals to the vast flow of light moving through space. And here's the quiet, powerful twist. If light sets the pace of reality, then the universe is not rushing past you. It is meeting you exactly where you are, one message at a time, building your world in real time as you move through it. In that sense, you are not late to the universe. You are perfectly on time. By the time you reach the end of this story, something subtle may have shifted. The room around you will look the same. The screen will glow the same way, but the idea of now will feel different. You will know that every moment you experience is being built for you, piece by a stream of light that never quite stops flowing. Feynman believed that the real power of physics was not in the equations, but in the perspective they give you. When you understand that light is the ultimate rule, the universe stops being a silent backdrop and starts feeling alive with messages in motion. Space becomes a vast web of connections, and time becomes the order in which those connections arrive. This is why the speed of light is not just a limit for rockets and particles. It is a limit for meaning itself. It decides which events can become part of your life and which ones will remain forever outside your reach. It draws the boundary between the world you can know and the world that will always remain a mystery. And yet, within that boundary, everything you care about exists. Your memories are light from the past, stored in the patterns of your brain. Your plans for the future are guesses about which messages have not arrived yet. Your present is the thin, glowing line where those two meet. Once you see this, even ordinary things change. A sunrise is no longer just a beautiful moment. It is the earth turning into a stream of ancient light that left the sun 8 minutes ago. A mirror is no longer just a reflection. It is a tiny time machine, showing you a version of yourself that already belongs to the past. Feynman loved these simple, strange realizations because they made the universe feel both humbling and intimate at the same time. You are small in a cosmos that stretches beyond imagination, but you are also deeply connected to it, tied into its rhythm by the same rule that guides stars and galaxies. So when you hear that light shouldn't be this fast, remember what that really means. It means reality needs a pace, a beat, a way to unfold instead of collapsing into a single, overwhelming instant. And as long as light keeps moving at its impossible speed, the universe will keep telling its story, one moment at a time. And somewhere in a quiet classroom or a dark night under the stars, someone else will ask the same question you just did, and the same stream of light will carry the answer forward, keeping the universe curious, connected, and endlessly unfinished for all time.